Okay, Descartes Rule of Signs. René Descartes is a guy who did a lot of study in coordinate geometry. So anytime there's some kind of a rule involving, graphing, which we're finding roots, that's graphing. Descartes did a lot of work in this. And he said if you have a polynomial function with real coefficients and the terms arranged in order decreasing powers of x. So in other words, descending order. And it's not weird. It's not like got square roots of 5 as coefficients or anything like that. So you got to, or in fact, square root of 5 would be fine. You could do that. It'd be hard, but we're not going to have anything like that. But really, you're not going to have imaginary coefficients. You're not going to have like I times x squared, or anything like that. But if you have a regular polynomial function with real coefficients in descending order, the number of positive real zeros of p of x is equal to the number of variations in sign of p of x, or that number decreased by an even integer. Okay, let me translate that into real words. Okay, because that's the official rule. Positive real zeros. Okay, real zeros, of course, numbers that make the polynomial equal to 0. Positive meaning bigger than 0, like 6, 2, 1/2, whatever, or even square root of 5. I mean, it could be a root. It's positive. Okay, the number of positive real zeros is equal to the number of variations in the sign of p of x. So p of x is some polynomial function. Let's say 3x squared minus 4x plus 1. All right. We go from term to term and look at the sign of each term. That term's positive. That's negative. That's a variation in the sign. That's negative. That's positive. That's a variation in the sign. So there's a total of 2 variations in sign here. What that means is there are either 2 or 0 positive solutions. Alright? So variations in signs, the sign changes. If this was 3x squared plus 4x plus 1, no variations in sign, there's no positive answers. Alright, so that's his rule. But again, it's either that number or decreased by an even number. So if there's 5 variations in sign, there's either 5 or 3 or 1 positive answer. All right? And then it says also the number of negative real zeros of p of x is equal to the number of variation signs of p of negative x. P of negative x is real simple to make. You take p of x, every even power of x stays the same sign, every odd power changes sign. So it'll be positive 3x squared plus 4x plus 1. Even power stays the same, even power stays the same, odd power changes sign. No sign change, no sign change, so there's 0 negative answers. That's how it works. All right? We, of course, are going to do bigger than quadratic functions because we're going to challenge ourselves, but that's basically what it is. So if you're asked to use Descartes' rule of signs, find me p of x, find me p of negative x, and then again, count variations in sign, and that establishes how many positive and negative answers there are. So when I see these words, use Descartes' rule of signs, the very first thing I do, I've got my p of x already there. I'm going to write p of negative x. I leave a little space, so I would actually copy this onto my paper, the p of x, leave a line, and then I put p of negative x below it. And again, the even powered signs stay the same, the odd power signs change. So everything I've underlined there stays the same. So x to the 4th is still positive, 5x cubed becomes negative. X squared stays positive, 5x becomes negative. Negative 6 stays negative. There's a reason why. You just highlight that. So just focusing on the first 2 terms. If I'm changing x to a negative x, because that's what I'm doing here, p of x, p of negative x, right? Negative x goes where x used to be. Whatever's happening to x is happening to negative x. So minus to the 4th power makes positive, sign stays the same. Minus to the 3rd power is negative, sign changes. So the odd powers are going to get an odd number of negatives, changing the sign. Even powers are going to get an even number of negatives, keeping the signs the same. So all even powered objects stay what they were. All odd powered objects change sign. Then I got to count variations in sign. So originally p of x, I've got positive negative is 1, negative to positive is 2, positive to positive stays the same, positive negative is 3. Okay, so positive change to negative 1, back to positive 2, stays positive, doesn't count, change back to negative 3. So there are 3 or 1 positive roots. Looking at p of negative x is telling us about negative roots. Positive stays positive, changes to negative, stays negative. So it has 1 sign change. So one negative root. That's the extent of Descartes' rule of signs. And again, all that did was it simplified things for us in this sense. If I'm doing the other rule, I got all these pluses and minuses, right? If I can find my negative answer, because there's one negative answer, right, out of the list, let's say it's -2, then I know the rest of the negative answers aren't the right answer. The other answers are positive. So now, instead of having 20 numbers to check, I've only got 10 numbers left to check. So that's Descartes' rule of signs. You can sometimes throw out some of these answers, or just make things a little simpler on yourself. Because again, our job is going to be to find all the answers. So we're learning some techniques to limit the number of choices we have.